Okay, Assalamualaikum warahmatullahi wabarakatuh and good morning. So today I will explain or I will discuss exercise 3.7, question number 3. So this one I'm asking you to do the exercise. So make sure you try first, alright, and then you can see this video lah for sure. Right, so if you read here, a company is in planning to install a new machine to assembly its product. The company is considering two types of machine, machine A and machine B, but will buy only one machine. Okay, so that's the story. Okay, the company will install machine B if the mean time, okay, here the mean time taken to assemble a unit of a product is less than the mean time taken by machine A. Alright, so here it's important because it's something to do with decision. Okay, when you do hypothesis testing, actually you make a decision. Okay, which one? Is it H null or H1? Okay, so that's a statement that they want to check lah. Okay, the following table shows the time taken in minutes to assemble one unit of the product on each type of machine. So you can see that machine A, machine B, okay, is a time. So if the question asks you what is the variable, it will be the time lah. Because what is 23 ni? 23 is a time in minutes, okay. So if you look here, how many samples you have? 1, 2, 3, 4, 5, 6, 7, 8. Right, so your NA equal to 8, and then your NB is also equal to 8. Alright, and then if you look this data, this is not dependent data. It's not paired data, isn't it? Machine A, machine A, machine B, machine B. Okay, so clear. It's a two independent sample or two independent. Alright, they didn't dependent to each other. So question A. At 10% significant level, so here you know your alpha is equal with 0.1. Test the difference in variability. So when we're talking about variability, we will look variance. Okay, so test the difference in variability between the two types of machines. So they didn't mention which one comes first. Okay, and then they want to see the difference. So what's mean difference? Is it equal or not equal? So this one will be not equal, isn't it? So they want to see either the population variance A, machine A, is it similar with population variance B? So this is your hypothesis. Okay, we solve question A first. So this is your first step. H now, H1. Alright, so your claim just now is population variance A, is it different with population variance machine B? So this is the claim. Alright, so here will be population A equal with population variance B. Okay, so here at this first step, you must clear. Is it one tail, two tail? Alright, so since when you deal population variance, two population variance, you will have F table, isn't it? F test. So this is the distribution of F, skewed to the right, not symmetric. Okay, so it will be left side and right side. Okay, and then here you will have actually alpha over 2. Here you will have 1 minus alpha over 2. Okay, so take note at this part you have two tail, two area like this. Okay, and then remember your alpha just now is 0.1. So alpha divided by 2 you get 0.05. Okay, so step number 2 is test statistic. Alright, so you have two population variants, so you only have one formula, which is F test. Okay, if you remember, even in chapter 2, when you have two population variants, you will use F table. Okay, which is F test lah. Alright, so what is the formula? Okay, you can see from the statistical table. Okay, from the statistical table, let's say here is AB. So here will be sample variance A divided by sample variance B. Okay, and then from here they didn't mention what is your S. Oh, sorry. What is your S? what is your, in this case, you just need S lah. Okay, for this one, in this case, you just need S. Okay, so you can calculate using calculator. Okay, again, make sure you look calculator, how to use this one, how to calculate this one, okay? Use calculator. No need to put the formula tu. Okay, so use calculator. Make sure you know x bar d, n minus 1. So this is your S. Okay, and some of you have SX. Some of you have SX lah. Okay, so this is this sample value, sample standard deviation. Okay, so if you calculate, okay, you get here 10.5536. Okay, so this is S square already. Okay, this is S square already, and the other one is 4, if I'm not mistaken. Okay, 4. So no need to put square lah. Alright, so here your answer will be, so here your answer will be 2.6384. Alright, so again, I strictly mention 4 decimal places everywhere. Otherwise, it will be KKS minus 1 too. Okay, if you look your test too, I deduct 1 mark overall. Okay, so this is your F test. Now, step number 3, you must have critical value. So, critical value you get from the F table. Okay, so F table, you have many pages, isn't it? Okay, but important, you must look what is the alpha. So here I want to show you how to find. Okay, so here will be nu1, nu2, isn't it? This one also nu1, nu2. Okay, so let's say right side first. Okay, so this one you will have F 0.05. What is your nu1? What is your nu2? In this case, nu A, nu B lah, isn't it? So remember, in the previous slide, all is equal with 8. So 8 minus 1 is 7, 7. So look at your statistical table. Okay, look 0.05. Where's the pages? So if you look in the statistical table, 0.05 will be page 55, 54, 55. Okay, so look, which one comes first? 7, 7. So if you look table too, okay, you will have here alpha 0.05. So you have nu1, nu2, isn't it? So look, which one comes first? This one, 7. So look 7 here, and then second one, 7. So this is the value that you want. So if I look table here, it will be 3.7870. So 3.7870. Okay, so that is the right side. Okay, however, important for the left side ni. Okay, I hope that you know how to do it. So let me show you here. So basically, you will have 1 minus 0.05, you get 0.95, isn't it? 0.95, and then you get 7, 7. Okay, however, because this is left side, you need to do 1 over F 0.05 7, 7. In this case, because the value or the new value is similar, okay, but basically you must twist. Let's say here just now is nu A, nu B. This one should be nu B, nu A. Okay, but when you read the table, okay, you read nu B first. So let's say in this case 7. So 7 will be here, and then 7. So you will get the same thing here, which is 1 over 3.7870. But then when you calculate this one, you get 0.2641. Alright, so this value is makes sense. Okay, because if you look figure here, okay, let's say I draw back the figure here. Alright, the right side is 3.7870 and the left side is 0.2641. So the left value should be lower than the right value. Okay, remember I said this is F distribution. You start from 0 until infinity. So that's why the left value should be smaller than the right value. Okay, so that is your critical value, step number 3. So step number 3 for F test ni, or for F table ni, is very critical. Okay, you must clear how to read the table, how is it the left side and everything. Okay, so now step number 4, decision. Okay, similar. Okay, reject H null when your F test is in the dark side. Okay, look, check this value. Where is it? Is it at the bright side or at the dark side? So if you look here, 0.26 is here, isn't it? Alright, so at the bright side. So your answer will be do not reject H null. So how to do it? Do not reject H null since you must have this, your F test, which is 2.6384 less than F 0.05, or you can say F table as well here, which is here 3.7870, and the other one you have F table, which is 0.2641. Okay, so here you decide reject or do not reject H null. So if you look here, do not reject H null. So there is a different invariability or not? So step number 5, you must look at alpha 0.1. Do you have enough evidence to support the claim? No lah. Okay, so you can consider like this. There is insufficient evidence. Okay, evidence to support the claim. Okay, what is it? The claim that there is a different invariability of machine A and machine B. Okay, so that is the solution for A. Okay, so important, alright. Step number 5, it depends on your step number 1. Okay, make sure you clear step number 1, then you can conclude here. Alright, so now if you look question B, okay, this one I will not discuss full, okay, but just give you some idea how to do it, because this one is in different topics, okay, in previous topic, okay, but it can be combined like this. Okay, which machine should be installed by the company to assemble its product? Test the hypothesis at 10% significant level and use the assumption of the condition variance based on your answer in A. So based on your answer in A, what is your answer here? Do not reject H null, isn't it? That's mean population variance A equal with population variance B. So that's mean from question A, you get population variance A equal with population variance B. And then if you look here, they want to see which one to be installed. So how you decide which one to be installed? You can look back at this third sentence here. Alright, the company will install machine B if the mean time. So when we are talking about mean, it will be mu. The mean time mu B, okay, is less than mu A. Alright, so that is the hypothesis. So this one, is it H null or H1? It will be your H1. Okay, so your H null will be, okay, I try put back here nicely. Okay, so your H1 just now you get from the question here, mu B less than mu A. So this is the claim. So your H null will be mu B greater equal with mu A. Alright, so this is 1 till your alpha is 0.1. Okay, so try do this. Okay, similar with previous subtopic though. Okay, and then this is the assumption that you must have. You get it from question A. Okay, but for this subtopic, we focus on A. So for final, it can be like this as well lah. Okay, I didn't say that this is the final question. No, I said it can be like this. Alright, so I think that's all for today. Thank you, class.